Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay Raj, back with another geometry video for you all. And today's lesson topic is all about isosceles and equilateral triangles. Now, before we jump into today's lesson, please make sure to smash the subscribe button down below, hit that like button on this video, as well as turning on post notifications by clicking that bell right below the subscribe button to get notified on any of our channel's latest posts at eCoreAcademy. All three of those things are very greatly appreciated, and of course, it'll help you as well in turn with all of our content. As I said before, we're going to be focusing on isosceles and equilateral triangles. I did many previous videos about the generic polygons, what they are, such as triangles, rectangles, squares, so on and so forth. We unlocked all the types of quadrilaterals and all the types of triangles. So we went in depth about the different types of triangles, what properties of triangles are, the triangle sum theorem, some laws of the triangles, and some different classifications. And this is more towards classification of triangles and how exactly we get to that step. So the three types of angle classifications are obtuse, acute, and right triangles, and then you also have coexistence with side lengths, which are also isosceles, equilateral, and scalene. So we're going to be focusing on mainly isosceles and equilateral triangles, but I will also mention scalene triangles since they don't necessarily have a special property, since they have no equivalent side lengths. So the whole theme and purpose of today's lesson is to discover what are some specific relationships amongst equilateral and isosceles triangles, and how can we apply them to problems. So I'll just be giving you an insight on how exactly they'll work with different problems. And I'll also be showing you different examples with scalene triangles as well. So let's jump right into it. So let's look at properties of triangles in general before we actually go into depth with equilateral and scalene equilateral and isosceles triangles. This is a bit more of a review if you haven't already watched my previous videos on triangles. So let's look at this slide over here. So all triangles have at least two acute angles, and it is the third that is used to classify the triangle. So what that actually means is that all triangles have at least two acute angles, and your third angle is what's actually used to classify that triangle. It's mandated that you have at least two acute angles due to the fact of the triangle sum theorem. So the triangle sum theorem will apply that. So you're originally given two acute angles, and then if you're either given an obtuse or a right angle or another acute angle, that same angle will give the classification of the triangle, whether or not it's acute, right, or obtuse triangle itself. So that's triangle sum theorem. And of course, all three angles have to add up to 180 degrees. So that's underneath the triangle sum theorem. And then this is true because coexistence can still be proved only by knowing the angle measures of a triangle. So that's very interesting because I know I showed you coexistence between side lengths and angles and how they can both be interrelated. But the only thing that you need to know in a triangle is merely just the angle measures. You only need one factor to know the other. Meaning, if you have angle measures, angle classification given for a triangle, or for just given the angle measures of a triangle, then you would already be able to figure out the side length classification for that same triangle. And I'll show you how actually that's going to happen, because there's only three different types combinations for each: angle classification and side classification. So we're just going to be focusing on utilizing different angles given within a specific triangle, and I'm going to show you how exactly we can use it in a problem, an actual problem format, and how we're going to actually discover exactly what the side length classification for that very triangle would be. So like I said, you just need to know the three different angles in the triangle in order to do so. As you can see here, we have two acute angles as shown, 25 degrees and 30 degrees. And of course, our obtuse angle here, 120 degrees, defines this triangle as an obtuse triangle. And this can also be classified by a side classification. This would be a scalene obtuse triangle, but I'll show you exactly how we're going to do that very soon after this slide. So let's look at isosceles triangles first. So this is part one of isosceles triangles. And let's look at the different parts of an isosceles triangle. So an isosceles triangle is a triangle with at least two congruent sides. And that also brings on another matter of fact that the isosceles triangle, even just because it has two congruent sides, it would also have two congruent angles. And I'll show you through a theorem how exactly that plays out in laws of geometry. And I'll show you a diagram to show you exactly what that's going to look like. So we have isosceles triangle, the definition. By definition, it does not necessarily include incongruent angles. It just it just implies two congruent sides, so a triangle with two congruent sides. And the legs of an isosceles triangle are the two congruent sides of an isosceles triangle. So those are the legs are both the congruent sides, and then of course your remaining side, which is your base, will be your non-congruent side to those two sides. So this is what an example of a leg would be. So I'll just draw out this isosceles triangle. And as you can see here, it's quite obvious that these two are the legs. Will indicate that by our congruence tick marks, and this is non-congruent to those. So these two would be the legs of the isosceles triangle. As simple as that. So those are your legs of the isosceles triangle. Isosceles triangles part 2. Let's look at the parts of an isosceles triangle, and we're going to go further extendedly to both. We're going to look at all the angles and positions of the side lengths as well. So the base angle in an isosceles triangle is either of the two angles opposite the legs. So if you look at the legs of a triangle, of an isosceles triangle, you have the two congruent sides, and basically each angle that is completely opposite, you can draw a diagonal from. Those two angles at the bottom near the base are going to be your base angles, and they're completely direct opposite, diagonal opposites from the legs of the isosceles triangle. And then you have the base of the isosceles triangle, which is the side included between the two base angles, and the base is just merely the side length that is not congruent, meaning you have your two legs and then you have your base, which is a one side that does not have any congruency to any other sides in the isosceles triangle. So I'll draw that out here as well. So we'll draw the same isosceles triangle with different legs. Okay. So if you look here, we have these two will be congruent. So these two will be our legs, congruent sides of this isosceles triangle. This is the non-congruent side, so this will be our base, the third side of the triangle, and then we have two angles here. And as you can see here, they're completely opposite from each side of the legs, each leg. So these would be your base angles. So I'll write that here, base angle and base angle here. And finally, for our last part of identification in parts of an isosceles triangle, part 3 of isosceles triangles, we have the vertex angle in an isosceles triangle. This is the angle that is opposite the base. So it's basically the remaining angle outside of the two base angles. So you have your two base angles and then you have your vertex angle. And that's just basically in an isosceles triangle. If we're saying that these two sides are going to be congruent here, I'll draw it in a different outlook. So this would be your base, and it's just the angle that is opposite to that very base. It's the angle that's directly opposite, meaning on a vertical outlook. It's going to be directly opposite from the base, and it is the remaining angle from the rest of these two base angles that are both opposite from the legs of this isosceles triangle. So those are your base angles, and then this is your vertex angle. Pretty simple stuff. Vertex angle. All right. Isosceles triangles part 4. That should say part 4. I apologize. Pass that out here. So parts of an isosceles triangle continued. Isosceles triangle theorem. So this is one of the theorems that goes along with the isosceles triangle. And that's going to further prove my point that I stated at the beginning of this video, where I said that you only need the angle measures of a triangle, in this case that we're going to focus on in this lesson, to actually identify the side length classification, isosceles, equilateral, or scalene, and you only need the all the angle measures in order to do so. So in the isosceles triangle theorem states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So all it's saying is if an isosceles triangle has two sides that are congruent, that means the base angles will also be congruent. So if it has two legs that are congruent in an isosceles triangle, that means the base angles will both be congruent. And the converse of the isosceles triangle theorem states that if two angles of a triangle are congruent, meaning if you have two equivalent angles, then the sides opposite them are congruent, making that triangle an isosceles triangle. So what I'm saying is, if you're given one example here, and you're indicated that you have, and you're not necessarily given that it's stated as an isosceles triangle. Say, for example, they say that these two sides are congruent. That means that these angles must be congruent. These two base angles must be congruent, making it a isosceles triangle. Isosceles an isosceles triangle, but not necessarily given the third angle measure. But if you're given these two angle measures, then you can then describe what kind of angle measure it is, and you can describe the whole classification. And the converse of the isosceles triangle theorem is much more common, because with that you can identify both worlds. So with the isosceles triangle theorem, you can only further state that the triangle will have two congruent angles, and of course you have two congruent sides, but that's only used to calculate what the side length classification for that triangle will be. But the converse gives you the angles, and in order for you to calculate what the angle measures are, and so you can figure out angle classification by doing that, and you can also figure out side length classification. So the converse gives you much more options there. So I'll draw this here. So this is for the converse. If you're given that these two angles here, these two base angles of an isosceles triangle, you don't know if it's isosceles yet, sorry, but if you're given that these two angles here are congruent, since you know these two angles are congruent and you're given their angle measures, you would then know that the upper angle here would then be the sum of these two subtracted from 180 degrees due to the triangle sum theorem. You would calculate the value of this angle, figure out what type of angle classification it would be, and then you would already know that it's an isosceles triangle because it has two equivalent angles. So these sides would be the legs of the triangle, isosceles triangle, because they're opposite the base angles. So very simple. So this is angle classification, and I'll just write here angle isosceles, just as a placeholder. Now let's move on to equilateral triangles, and then I'll show you a bit of a glimpse on scalene triangles, and we'll just prove our point all together and why exactly this whole situation will work out. With the angle classification, automatically proving your side length classification and proving coexistence immediately. So let's look at equilateral triangles now. So equilateral triangle properties. Equilateral triangles are probably the most proper of triangles, very simple to work with, and they have very simple properties. So the equilateral triangle is a triangle with three congruent sides and three congruent angles as well. That's already given. And because of that, the corollary states, meaning a specified situation with equilateral triangles, states that if a triangle is equilateral, then it is equal angular, meaning it has equal all three equivalent angles on its interior angles. And each of the interior angles must be 60 degrees. So all that's saying is an equilateral triangle must automatically have 360-degree angles and all equivalent side lengths. So I'll just draw that out here. And that's just saying that you have three congruent sides and three congruent angles. You just divide 180 degrees, which is through the triangle sum theorem, divided by 3 to get 60 degrees. So these three sides are going to be congruent, and these angles are all going to be 60 degrees and congruent as well. Just right here, equilateral triangle. All right, now finally, let's look at scalene triangles, and we'll prove our point all together and what exactly I'm trying to convey to you, with the angle classification automatically implying side length classification. So angles of scalene triangles, all angles of a scalene triangle will be at different, sorry about that, all angles of a scalene triangle will be of different measures. And that can be proven by the fact that if you look at the relationship with an isosceles triangle, any triangle that has two equivalent angles will automatically be an isosceles triangle due to the isosceles triangle theorem. And then for an equilateral triangle, any triangle with three congruent angles, we know that if there's three congruent angles in a triangle, they must all be acute angles. And if they're three congruent triangles, they must all be of 60-degree measures, because 180 divided by 3 is 60. So that means it's automatically an equilateral triangle. So the only other case is that you have three angle measures that are of completely different measurement, and that'll be a scalene triangle, which means all three side lengths will be of completely different measurements. So an example of that would be, and yes, you can have obtuse angles in this as well as right angles as well. So if we're given this triangle here and we're given three different angles, and they're expressed that they're not equivalent, they're not congruent, all of different measures, then you can automatically tell that the side lengths will be not necessarily correspondingly, but they will also be of different measures as well, automatically making this a scalene triangle. So as simple as that, we can just prove that all three types of of each pair of coexistent classifications, angle and side length, the angle classification automatically proves your side length classification as well. So that's very important to know. And very simple. It saves you a lot of steps when going through the process. You don't need as much information, and you can cut down the process and the time that it takes. All right, everyone, that'll be it for today's video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below and turn on post notifications so you don't miss any of our newest uploads. Visit our website at www.ecoreacademy.org. We'll have that link in the description as well. At our website, we have full unlocked access to what actually we give as an e-learning platform, as our own educational platform as well. We have videos organized into different course studies. We have all other contact information, different perks, events, schedules, all that sweet stuff, really cool accesses. And we also have access to note sheets, worksheets, and quizzes that go along with each and every single video. And they also are organized into different lessons where we actually have a new implementation where we track your progress on the website itself. All you need to do is make an account for free. So please make sure to do that. It can only help you guys. You can also email us at eCoreAcademy@gmail.com. We have the link down in the description below as well. You can reach out to us if you have any questions, or if you just need some technical support, or if you just want to reach out to us in general. And finally, please visit our socials in the description box below at Facebook, Twitter, and Instagram. Check out what kind of content we have there at eCoreAcademy. Check us a follow and see if you can share any of our videos to those who might need it through our mediums and to those who might find it interesting. Once again, everyone, this has been AJay Raj. I had a pleasure making this video. I hope you enjoyed, and I will see you all in the next one. Peace.